My students, the previous class we see some problem contained exercise 1.1. Now we move the next exercise. We already know the concept of the functions and relations. Now we will recall the relation of the functions. First of all, I say a one-to-one function. So there will be two sets, A and B. You know very well every function is represented by in four ways. This is an arrow diagram, set of ordered bar, graph and the table. But we do all the problem in an arrow diagram for a easy convenient. I solve all the definition in an arrow diagram. I will give one example of a one-to-one function. I will take two sets. The sets names are A and B. The relation is F. Is our choice will be take any letter. It's a small letter. And is a one-to-one function. For suppose A has three elements 1, 2, 3. And B has suppose A, B, C and D. So the set A contains three elements. The set B contains four elements. Suppose 1 is mapped with A, 2 is mapped with B, and 3 is suppose mapped with D. Now we say the function is called a one-to-one function because each and every element is mapped with a single element. And also excessively one event on element C is lies in B. You know very well it is called the domain and it is codomain. In codomain so many elements is missing is possible. So this is the example of a one-to-one function. And also I say it is not a onto function. When we say the given function is onto, each and every element in codomain as a pre-image, then we say the function is onto. But it is just one-to-one. One extra element C is there. There is no pre-image. Therefore we say it is just one-to-one. But it is not to onto. Now next one. One-to-one and onto. The function is both one-to-one and also onto. For example, I will take the letters. We will take any letter. Now suppose the function name is G. C contains 1, 2, 3. And suppose D contains 1, 4, 9. That is all of the square number. 1 is mapped with 1. 2 is mapped with 4. And 3 is suppose mapped with 9. Now we see each and every element is mapped with a single element. And also all the element in codomain has a pre-image. Therefore now we say the function G is called both one-to-one and onto. Each and every element is a single image. And also every image in codomain has a pre-image. Therefore we say the given function is both one-to-one and onto. Next. An example of a neither one-to-one nor onto. It is not one-to-one. And also it is not onto. A, B, C, D. Suppose the set A contains four elements A, B, C, D. The set B contains 1, 2, 3, 4, 5. Suppose 1 is goes to A is goes to 1. B is also suppose goes to 1. The image of A is 1. The image of B is also 1. C goes to 3. And suppose D goes to 5. Now we say is a one-to-one. Is not one-to-one because A and B have both the same image 1. So it is not one-to-one. And also I say it is not onto because the element 2 and 4 has no pre-image in A. So I say which is the name of the function. It will be taken as F, G, H like this. Now I say the function S, F is not one-to-one and also is not onto. So we say it is neither one-to-one nor onto because A and B has the same image. And the element 2 and 4 in codomain has no pre-image. Therefore, it is an example of neither one-to-one and not onto. Next, not a function. I will give an example of not a function. Same set. So the set symbol is indicated within this box or within this symbol is your choice. Suppose the name of the function is h. Now I write one example of a not a function. Suppose A contains the element is 1, 2, 3, 4. The element B contains 5, 10, 15 and 20. 1 is suppose map with 5. Same 1 is suppose map with 10. And 3 is mapped with 15. 4 is mapped with 20. Now I say it is not a function. You know what is the reason? We tell the two reasons. The element 2 in domain has no image. So in each and every element of domain has an image. You see the element 2 has no image. Therefore we say f h is not a function. And also the element 1 has 2 images. The element 1 has 2 images. Here the 2 elements have the same image is possible. But the element has a unique image only possible. But here we see the element 1 has 2 images. The images are 5 and 10. Therefore we say h is not a function. We tell the two reasons. But in our exam or test, just we tell any one of the reason. The one reason is the element 2 in domain has no image is the one reason. Or the element 1 has 2 images 5 and 10 in a codomain. Therefore we say the function h is not a function. Okay, it is not a function. And also we know very well what is meant by a constant function. This is one. Each and every element has the same image. So all elements goes to a single element. We say it is a constant element. And next one is an identity function. What is meant by identity function? Both the elements are same. 1 is mapped with 1. 2 is mapped with 2. Suppose in this case we say the function is identity function. In 1 mark there will be x. What is meant by a constant and what is meant by an identity. And next I introduce a new concept. What is the difference between an open interval and a closed interval? So open and closed interval. In your 10th standard level we see just an interval. But in 11 and 12 we see some elaborate sums. So this symbol parenthesis is a symbol of an open interval. And within a square bracket we use the symbol is called a closed interval. What is the difference between an open and a closed interval? Just only one difference. Suppose in this interval I will take 2 values 1, 5. Here also I will take 1, 5. What is the difference between these two intervals? The end points is not lies in the open interval and the end points is lies within the closed interval. It is the only difference. You see observe 1, 5. In between 1, 5 there will be a 2, 3, 4. So the values is possible in the open interval. But the element 1 and 5 is not included in this interval. But in closed interval, the starting value is a 1 and the end value is a 5. Suppose we see in elaborate, is a minus infinity and a plus infinity. Is the middle 0. So I will take it is a value of 1 and it is a value of 5. Suppose we indicate the open interval 1, 5, all values is possible between this 1 and 5. It's not only 3 values, 2, 3, 4. 1.1, 1.001 up to 5 before number is 4 or 4.5 or 4.6, 4.7, 4.8, 4.9, 4.999. All value is possible except these two values. So this is the nature of the open interval. But in the closed interval, the end points is also lies. What is the starting value of this closed interval is 1. The final value of the closed interval is 5. So this is the difference between an open and closed interval. So in an open interval, the end points is not lies in this interval. Closed interval, the end points is also include. So the starting value is the first number and the last value is the last number of the interval. Okay, now we move the exercise 1.3, the third one. Write the values of f. That is to write the values of the function f at some points is given. Minus 3, 5, 2, minus 1, 0. That is to find these 5 values. If f of x has some 4 values. So x square plus x minus 5. If x belongs to, what is the name of the interval? Open interval. Minus infinity to 0. Suppose x value is minus infinity up to 0. F of x is defined as x square plus x minus 5. And f of x has another value. Is x square plus 3x minus 2. When it is possible, suppose this x belongs to the open interval 3, infinity. So 3, the next value of 3 is 4, 5, 6 like this. All values of x more than 3. f of x is defined as in this manner. And f of x has just x square. When it is possible, if the value of x belongs to 0, 2. And f of x as x square minus 3. The value of f of x is x square minus 3 is otherwise. Where the otherwise means except these three values, other value of f of x is defined as x square minus 3. Now we find the values of these functions. So but f of x has some 4 values. Now we find each and every one. First one, to find the value of f at minus 3. So we put a heading f of minus 3. For convenience, first of all we write a heading f of minus 3. So what is the exact value of x here? Minus 3. When x is equal to minus 3, how to define f of x? When x is equal to minus 3, so x belongs to minus infinity, 0. So in this interval I say the value of minus 3 is lies. Minus infinity means all negative value up to 0. So f of x as x square plus x minus 5. Next, I replace exactly the value of x is minus 3 because we find f of minus 3. So I replace x by minus 3 here. Minus 3 the whole square plus into minus 3. The symbol, the value of x is minus 3 minus 5. Minus 3 the whole square is 9. Plus into minus is minus. Minus 3 minus 5. So the value of f of minus 3, 9 minus 8. 9 minus 8 is 1. So f of minus 3 value is plus 1. So first one is over. Next, to find the f at 5. So I put a heading f of 5. Now I check. When x is equal to 5, how to define f of x? So now we see the function. When x is equal to 5, f of x how to define? You have any idea? So you see the second interval. 3, infinity. So 3, what is the next number? 4, 5, 6 like this. It goes up to plus infinity. So 5 lies in this interval. Therefore, when x is equal to 5, how to define f of x? X square plus 3x minus 2. So f of x, x square plus 3x minus 2. Now I replace x by 5 because we find f of 5. So f of 5 is equal to 5 square plus 3 of 5 minus 2. The value of 5 square is 25 plus 3 5s are 15 minus 2. 25 plus 15 is a 40 minus 2. So f of 5 value is 38. Is over. The value of f of 5 is 38. Next, we find the third one. We find the value of f at 2. So I put a heading f of 2. Now I check. When x is equal to 2, how to define f of x? When x is equal to 2, how to define f of x? You see the interval. In this interval, 2 is impossible because negative value, last value is 0. In this interval also 2 is impossible because the starting value is 3.1 something. In this interval 2 is possible. We already tell in a open interval the end point is not lies in this interval. Okay, so 0, 2 is there, but 2 is not lies. So in all these three intervals, the number 2 is not included. So when 2 lies is otherwise. So except this all this interval, 2 lies in this interval. So the value of x is equal to 2 is lies here. So when x is equal to 2, f of x is defined as x square minus 3. So f of x is x square minus 3. Now I replace x by 2 because we find f of 2. So f of 2 is equal to 2 square minus 3. 4 minus 3. So f of 2 is equal to 1. Next, to find f of minus 1. So I put a heading f of minus 1. Next, we check How to define f of x when x is equal to minus 1? When x is equal to minus 1, how to define f of x? So in this interval, I say the value of minus 1 is less. You think? Because minus infinity up to 0. What is the previous value of 0? Minus 1, minus 2, minus 3, like this. So when x is equal to minus 1, f of x is defined as x square plus x minus 5. So f of x is equal to x square plus x minus 5. Now I replace x by minus 1. So we replace x by minus 1. So f of minus 1 is equal to minus 1 the whole square plus into the value of x is minus 1 minus 5. Minus 1 the whole square is 1. And plus into minus 1 is minus 1 minus 5. Plus 1 minus 1 is cancelled. So f of minus 1 value is minus 5. So the value of f of minus 1 is minus 5. Now we find the last value. To find the function when the value of x is 0. So I put a heading f of 0. Next we check when x is equal to 0, how to define f of x. When x is equal to 0, how to define f of x. Now we go to the sums. So in this interval, 0 is not included. Here also 0 is not included. Here also 0 is not included. So 0 is when included, otherwise. So x square minus 3. Next, f of 0. 0 square minus 3. We leave as 0 square. So f of 0 value is equal to minus 3. So the value of f of 0 is equal to minus 3. Now I finish the third sum. The same model sum lies in the second sum. In exercise 1.3 I finish the third one. The same model sum it lies in the second sum. We must try in our class note. Now we move the fourth one. State whether the following relations are functions or not. So relation is given. Now to check the relation is a function or not. If it is a function, check for one-to-oneness and onto-ness. Suppose if it is a function, we check it is either one-to-one or onto. If it is not a function, state why. Suppose we say it is not a function, you tell the reason. There will be two subdivisions given. The first subdivision is A is a set. It contains three elements A, B, C. And the function f is defined as is given in a ordered pair A, C, B, C, C, B. And f is a function from same A to E. Now we check it first of all is a function and we say it is a one-to-one or onto. So it given in a set of ordered pair. For our easy convenience, first of all I convert the ordered pair into the arrow diagram. And second subdivision is also given. Now we do one by one. First we finish the first subdivision. There will be a two function is there. Both the functions are A. So A. The relation is called f. Given in the question, f is a function from A to A. So A contains how many elements? Three elements. A, B, C. So A, B, C. Here also I write A, B and C. Because both are the same sets. So A, B, C. Domain is A and codomain is also A. So how to map? You see the question. A, C. So A is mapped with C. So this A is mapped with C. B, C. So B is mapped with C. So this B is also mapped with C. And C, B. So C is mapped with B. So this C is mapped with B. What is our question? First of all, we check it is a function or not. We say it is a function or not. Each and every element of domain has an image and also is a unique image. So we say it is a function. Next, we check it is a one-to-one or onto. We check it is one-to-one. First of all, it is not one-to-one because A and B has the same image as C. So it is not one-to-one. We check it is onto. It is not onto. Why? In codomain, the element A has no pre-image. Therefore, first of all, it is a function and also it is neither one-to-one nor onto. So we must write the reason also. it is a function. F is a function. First of all, we tell it is a function or not. F is a function. Also, it is neither one-to-one nor onto. Also, it is neither one-to-one and not onto. So, first submission is over. We already tell the reason. Because this two element has the same image. The element here has no pre-image. So, function and also is neither one-to-one nor onto. Now, we see the second submission. X. Okay, X is a function. It has three elements, x, y, z. And F is a function is related with this ordered bar. Here also F is a function from x to x. We check it is a function or not, and we check it is a one-to-one or onto. The second submission. The name of the function is x. Here also x. So domain and codomain are same. The relation is called f. You see, the relation is called f. X, the values of x is defined as x comma y comma z. The values of x is x, y, z. So here also x, y, z. Now, you see the order pair x comma y. So x is mapped with y. So x goes to y. Next, x comma z. X is goes to z. This x is goes to z. Next, z comma x. Z is goes with the x. Okay. For easy element, I write in an arrow diagram. Now we say it is a function or not. First of all, we check. It is not a function. I say. We tell the reason. There will be two reasons. The element y has no image. First of all, and also the element x has two images, y and z. Therefore, here f is not a function. We tell the reason also. If it is not a function, state why. So here f is not a function. First, we indicate this function f is not a function. We tell that two reasons. Since or because x in domain as two images. Okay, this x in domain as two images. What is the image's name? Y and z. Y and z in codomain. This reason is enough. But we write one more reason also. So I say the one reason. And the element y in domain has no image. So also y in domain has no image in codomain. What is the reason to tell the reason? In our question, if it is not a function, we tell the reason also. So in your exam or test, we write any one of the reason is enough. For understanding purpose, I write both one. You write if in these two cases, we write any one. X in domain has two images. That's why it's not a function. It's one reason. The another reason is in a domain, one element has no image. There also the given function is not a function. Therefore, the given relation is not a function. The fifth one. Let A 1, 2, 3, 4. The set A contains 4 elements, and the set B also contains another 4 elements. A, B, C, D. Give a function from A to B. Now we give a function from A to B for each of the following. There will be a 4 subdivisions given. Now we give a function. First one is neither one-to-one and not onto. Now we form a function. The function is both. It's not one-to-one and also is not onto. Second one, not one-to-one but onto. Is not a one-to-one but onto. Third subdivision, one-to-one but not onto. And the fourth one is a one-to-one and onto. You see, both the sets have first of all equal number of elements. It's not the same elements, but equal number of elements. 4 elements. Here also 4 elements. Now I say the second subdivision and the third subdivision is impossible to form a function. Why? You see the first one, not on one to one, but onto. You know very well onto means each and every element in codomain has pre-image, but not onto. Exact 4 elements is there, so it's not onto. So second subdivision is impossible. And the third subdivision also I say impossible. It's a one to one, but not onto. Suppose one more elements is less or more, is possible to one to one and not onto. But equal number of elements is there. 1 to 1 means each and every element mapped with one element only. Therefore, 1 to 1 and onto is possible, but 1 to 1 and but not onto is impossible. So we say one by one. What is our first one? It's a neither 1 to 1 and not onto. I put a heading. Neither 1 to 1 and not onto. So for our easy purpose, I will put the name of the function is f. The name of the sets A and B is given. Okay, in arrow diagram, I will create the function name is f, and the sets names are given A and B. Next, we write the elements of A and B. The elements of A, 1, 2, 3, 4. The elements of B, A, B, C, D. Now we form a function. The function is neither 1 to 1 and also is not onto. So that's why it's your choice. 1 is goes to A. 2 is also goes to A, because we need neither 1 to 1, it's not 1 to 1. Therefore, this 2 element has the same image. And suppose 3 goes to C. 4 goes to D. Now I say the function is f is neither 1 to 1 nor 1 to B. Check. These 2 elements have same image, therefore it is not 1 to 1. And also the element B in codomain has no pre-image. Therefore the function f is neither 1 to 1 nor onto. F is neither 1 to 1 and not. So we create a function. The function name is f, which is both neither 1 to 1 and also is not onto. And now the second subdivision. What is the heading of the second subdivision? Is not 1 to 1 but onto. Not 1 to 1 but not onto. So we create a function is both 1 to 1 but it is not onto. Not 1 to 1 but onto. So it's not 1 to 1 and also it is onto. So no need the diagram. The answer is impossible. We can't form a function both 1 to 1 and not onto. For our understanding purpose, I draw the diagram. The 2 sets. The set's name is A and B. The value is 1, 2, 3, 4. A, B, C, D. Now we create a function. Suppose the function is same f. It is not 1 to 1, but it is onto. We see it's impossible. It's not 1 to 1. 1 goes to A. Suppose 2 is also goes to A. So it's not 1 to 1. Okay. 3 goes to B and 4 goes to C. We see this one. We see is not 1 to 1. Okay, it's not 1 to 1 is possible. But onto is impossible here. Why we say it is not onto? Because the element D has no pre-image. Suppose the D also goes to C, sir, it's not a function. Suppose the element 4 is goes to D. We say the given one is not a function. So just we write the answer is impossible A wins. Reason says A and B have equal number of elements. Because A and B have equal number of elements, therefore is not 1 to 1 and onto is impossible. Next, the third one. What is the third one? 1 to 1 but not onto. 1 to 1 but not onto. I said this one is also impossible. All are 1 to 1 but not onto. So no need the diagram. The diagram for our understanding. Suppose we need a 1 to 1 first of all. Okay, we create a 1 to 1. So each and every one. 3 goes to C, 4 goes to D. We say it is 1 to 1. Okay, each and every element has mapped with 1. But not onto. It's not onto is impossible because B has just 4 elements. So each and every element has pre-image. Therefore, it is also impossible. The reason is same. We read the same reasons. Since A and B have equal number of elements. That means we can't form a function is a both 1 to 1 and also is not 1 to. So the third subdivision is wow. Now we come in the fourth subdivision. What is our fourth subdivision? Is a 1 to 1 and onto. 1 to 1 and onto is possible. Is an example of this one. So A, B. So the set A and the set B. A contains 4 elements. The elements are 1, 2, 3, 4. The set B contains 4 elements. A, B, C, D. And we create a name of the function is G. Is your choice. If we take any one. Now if we take both, it is 1 to 1 and onto. So each and every element is mapped with 1. And also we see it is onto. Because each and every element in codomain has pre-image. It's not only goes to, one goes to A. So one goes to B, one goes to C, one goes to D. Is your choice. Suppose one goes to B, then 2 goes to A. So now I say the function G is both 1 to 1 and onto. So G is both 1 to 1 and onto function. So if you understand very well the concept of the functions, all sums are very easy. First we understand whether the given relation is a function or not. Suppose if it is a function, then we check it is a 1 to 1 or onto, or is neither 1 to 1, is not onto. Suppose if it is not a function, we must tell the reason also. There will be 2 reasons is not a function. The one reason is, suppose any 2 elements has the same image, then the given one is not a function. And also, one element in domain has no image, then also the given relation is not a function. So in these 2 reasons, the given relation is not a function. Suppose if it is a function, so many types is there. So we do each and every types. The same model sum lies in example also. We must try in our class note.